pen in their hand? Yeah. Perfect. Looks like it. 36, start with number 6. And number 6, saw a wide range of different answers here. You should get a fraction as your result. So let's see how we get to that point. First, we're going to split our equal sign like so. We take a look at our z. I see that I'm multiplying it by -5 and then subtracting 6. So if I reverse PEMDAS, I want to get rid of this subtraction first. What's the inverse of -6? +6. Hit both sides with that +6, crossing out on the left, bringing down what we got remaining, -5z. Good morning. 3 plus 6 on the right-hand side is going to give me what? Thank you. 9. Go ahead and move back. -5z equals 9. Now, just because this 5 is negative, a lot of times our brain tells us, oh, I'm going to add 5 to both sides. But what operation should we actually do on both sides? If we're multiplying here, division. Thank you, Roz. We divide by -5, divide by -5, cross out on the left once more. -5 over -5, that's just 1. And we're left with z equals, can we simplify 9 over 5 at all? No. So z is equal to -9 over 5. I saw some, -1.8s as I was walking around. Just keep it as a fraction. As I've mentioned before, I don't like decimals. We want to keep all of our answers as fractions whenever we have a fraction as an answer. Just like so. Anybody get that for number 6? No one got that for number 6? Oh, a couple people. Good. That's the one I got a lot of questions on yesterday. So, is there any clarification you need on number 6, or does that look okay? All right. Number 7, we got another little fraction in here, but we're going to bust that fraction out. First thing we want to do is what? Line through the equal sign. That's right. What's the first inverse operation that we want to do? So we've got division here. We've got addition there. We always want to start reverse PEMDAS, so we're going to get rid of this addition sign by doing -6 on both sides. If we can combine these numbers on the right to get one single number of 3, it's going to make this multiplication a little bit easier. We're not going to have to multiply 3 by 6, 3 by 9, and then subtract. We want one variable, one constant, and that's going to kind of be what we're talking about today. If we're dividing x by 3, what's the inverse of dividing by 3? Multiplying by 3, thank you. Both sides, 3 over 3 crosses out. And 3 times 3 gives me what? 9. Let's just, for example, say we plug that x value back in on the top here. Right? X over 3 becomes 9 over 3 plus 6. What would 9 over 3 simplify to? 3 plus 6 equals 9. Does 3 plus 6 equal 9? Yes, it does. 9 equals 9 is true. So this answer is correct. So it's nice and easy for us to check our work and make sure we did something, or to check to see if we did something wrong, making sure we did everything right. Just plug that answer back in, solve it out, see if you get a little true statement there at the end. All right. Dropping down to 10. Number 10 was a little bit tricky too. We got x over 4 equals 1 over 4. I'm going to rewrite this out here just so I have some more space. I'm going to split this up. Pretty easy to tell what's my left and right side because there's not a whole lot going on. Roz? For number 6, yeah. So, great question. We've got -9/5, right? We could turn this into a decimal and get -1.8, but we just want to keep it as a fraction. We don't want to do we don't want to do more work than we have to do. If we had something like 10/5, we could simplify that, right? But 9/5 cannot be simplified. That's just 3 times 3 over 5 times 1. There's no common factors on the top and bottom that we could circle up and cross out. So we just leave it like that. -9/5. There's nothing more we can do with it. If we plug that back in, it would be a little messy, but we would end up getting 3 is equal to 3. Is that? Okay, cool. I know it's a little tricky. Fractions are always kind of difficult, just like down here in number 10. So, again, we always want to ask ourselves, what are we doing to x? What's the operation we're performing when we have x over 4? What's the operation? Are we dividing by 4? Are we multiplying by 4? We're dividing. So the opposite of that would be to multiply by 4 on the left and multiply by 4 on the right. What happens with this 4 and this 4? We cross it out. What happens with this 4 and this 4? We can cross those out as well. It's the same thing, right? 4 over 4 gives me 1 and gives me 1. So all we have left now is x equals 1. Right? All my 4's cancel out. And there's an even easier way we could do this. If we see that every term in our equation, and this is going to help us out in January when we come back to this, if we see that every term in my equation has the same denominator, we can just get rid of those denominators. We can pretend they're not even there. All we need to focus on is x equals 1 across the top. Boom. That's exactly what we got doing it with our little process. X is equal to 1. It's going to help us out a lot when we've got, 6, 7 terms in an equation. Thank you. We got to give them all the same denominator. But that's down the road. We'll work up to it. Does that sound good on number 10? Okay. Number 11, y over 2 plus 12. This is kind of like our warm-up. Looks very similar. I'm going to split my equal sign. First thing I want to do is what on both sides? Subtract 12. Cross those 12s out. 12 minus 12 is 0. And what does 13 minus 12 give us? 1. So we've got y divided by 2 equals 1. What's the inverse of dividing by 2? Multiplying by 2. Again, 2 over 2 on the left crosses out to give me 1. And what does 1 times 2 give me on the right? 2. Just like that. Questions I could answer about 11? Last but not least, number 12. Now this one's another kind of tricky one here. What's the first inverse operation we want to do? Do we want to divide both sides by 7?
Add.
Well, we're adding 19, right? So what's the opposite of that? Subtracting 19. What is 19 minus 19? 0. We could cross those out. And on the right-hand side, we get 19 minus 19.
That's still 0.
Still 0. But because that's the only number we have on the right side, we actually have to write our 0. Whenever we have an equation like this, right, we can think of it kind of like volleyball. The equal sign is the net. We've got a team on the left and a team on the right. Okay, we can't just have nothing at all on one side. There's always got to be something, even if that something is 0. So we got 7z equals 0. Again, whenever we have a number right next to that letter, we're multiplying. So it's the inverse operation for multiplying. Dividing. Divide the left by 7. Divide the right by 7. Thank you. 7 over 7 cancels out. And what's 0 divided by 7? 0. Anytime we've got 0 divided by anything, it's going to give us 0. Yeah, Ross.
Why did you subtract 19?
One more time.
Why did you subtract 19?
Subtract 19? Great question. So if we look at z, right, we always want to think about what are we doing to z. Oops, why is that not? So I see that I'm multiplying z by 7, and I'm adding 19 to that. What's the opposite of adding 19? Well, that's subtracting 19. From the left and from the right. Then I can divide after that. Thank you, sir. Exactly. And every single time there is a subtraction sign, we add plus 4, plus 4. Because what we want, again, on the left is to cross those numbers out. The only way to cross them out is by doing the opposite operation. That's okay. Take your time. Make the changes that you need. There's no rush. We just started this unit, so we've got the rest of the term, 3 weeks, to get all this stuff done. If you see a plus 25, you know that you're going to have to do minus 25. If you see a minus 5, you got to do the opposite, which is plus 5. Yeah. Great question. Good thing to bring up. All right, any last minute questions here on, what is this, 36? Perfect.